In Module 5's Sabermetrics track, we're going to be talking about runs estimators. And we've already talked about this before, but I'm going to wrap it up in one segment here. So runs estimators. How do we estimate runs in the game? Well, we've seen this already. We saw this the first module, the first week we were together. Right away, we started plotting team runs scored. We started to get to the idea of how do we think about team runs scored? We graphed many different things against teams runs scored to try to get a sense of which offensive statistic best correlated with this major idea of runs scored. This is a fundamental sabermetrics principle. We start with this, but then there's a broader concept of how we best estimate runs. And we went through the different coefficients of determination for these different statistics by looking at R-squared. There are other methods to measure the accuracy of any statistic for what you're trying to measure. We just went with the simple one, R-squared, because it shows up using various programs that are commonly used by folks to get at this idea of correlation, how strongly something is correlated. So we looked at on-base percentage. On-base percentage was one variable we looked at. We also looked at on-base plus slugging percentage, OPS. And that actually does very, very well. It's a nice, easy look at offensive performance. And we also looked at runs created, a very simple formula from Bill James, and that had a very nice R-squared value, a coefficient of determination, which tells us how well this statistic does at estimating team runs. And we can see by eye how well runs created does. So here are a couple of our estimators graphed. We put up here on-base percentage and runs created just to remind us what run estimators are. On-base percentage is a real measure of something. It's actually got important meaning in the game. It means something. That's different than, say, OPS. OPS is a beautiful, quick and dirty summary statistic, but OPS has no units. It doesn't estimate anything. It's just a number. Now, runs created, on the other hand, runs created is an estimate of runs. It is a runs estimator. It tries to get at runs. Look at the units on the y-axis if you need any convincing at all. These units line up pretty well. The team runs scored is in the same scale range on both the x and the y-axis. Runs created is trying to get at runs. It's trying to estimate runs. That's different than OPS and others. Now, there are other runs estimators that have been made. It seems like in the early 80s and 90s, it was the time of run estimator creation. It seemed like every sabermetrician worth their salt had to come in and estimate runs. We've seen and talked briefly about Pete Palmer's linear weights. Pete Palmer's linear weights are putting an average value on each of the offensive events. So it's different than runs created. Runs created has this idea that you will multiply, here's runs created, you'll multiply this idea of getting on base. Getting on base here is represented by hits plus walks. And if you multiply getting on base by total bases, which is some measure of advancing runners, the more bases you get on your hit, the more you're going to advance other runners. So this is some measurement of runners advancing following a hit. And then, of course, you divide it by opportunities. At-bats plus walks is some rough measure of plate appearances. So runs created gets at this idea of getting on base, not making an out, that's this here, plus this idea of moving runners along, represented by total bases, divided by opportunities. Plate appearances, a rough measure of plate appearances. So that's runs created, and it makes sense, and we can see by the scale again. The scale here is very similar to the scale here. So it really is a runs estimator. It really does try to estimate runs, which is what we're after. Pete Palmer's linear weights does it very differently. He tries to estimate the value, the average value of different baseball events. He wants to get a run value for all events and plays to get ultimately the average runs for every play, the average runs per play. So a single in linear weights is worth about 0.46 runs. 0.46 runs. Now this is the average case. So on average, a single will offer this many runs. In other words, it'll create an opportunity for a runner on base. It'll potentially advance other runners around the bases. And what Pete Palmer does is he does this for all different events. He does it for singles, doubles, triples, home runs, walks, stolen bases, caught stealing, hit by pitch and walks are put together. So hit by pitch is also in linear weights. We also have a negative term in here for outs. And outs is estimated by just at-bats minus hits. So outs made by batters is a negative quantity in linear weights. Caught stealing is another negative quantity in linear weights. Depending on the version of linear weights, you actually also talk about outs on base. He calls it OOB, that's negative. These are the different events that Pete Palmer puts weight on as he creates the average case. So on average, a single is worth 0.46 runs. In other words, when you take all singles and their contribution to runs, you put them together and you look at their run creation, how they generate runs, it's 0.46 of all runs. The coefficient for outs, the number which estimates outs is 0.25. So every time you're making an out, there is a long list minus of runs estimators runs developed in the 80s and 90s. So this is how we can put together an estimate. So there's a whole bunch of these different linear weights type runs estimators. Palmer's was the very well-known estimator. Jim Furtado did another one called extrapolated runs. What we're going to do is use the SQL Sandbox and our studio to look at a few runs estimators before we go on to talk about advanced thinking about runs estimators today.